Okay, so again, this is Matter and Change, Chapter 2. And this page is funny. What's a matter? I think it's supposed to be what is matter. I thought she thought that would be kind of clever. I probably shouldn't do this if I'm recording, because then she'll look at it and see that I'm making fun of her. Oh well. So anyways, matter is anything that has mass and occupies space. Mass and occupies space. Those are the only two requirements that matter has to have. And the simplest form of matter is this people over here. These 118 people over here. Those are the simplest breakdown of matter. Those 118 elements. Okay? Now mass is the amount of matter an object contains. And it's really important that we stop here and talk about what mass actually is. And I'm going to write this in here. Mass does not equal weight. Mass does not equal weight. Okay? Weight is a variable. Did you guys all know that? Not a variable by like how much you eat or exercise. Your mass is variable by how much you eat and work out. Does anybody know how your weight might change? Right here.
Gravity.
Gravity. So then how come your weight doesn't change on Earth? Because the force of gravity on Earth, it's a constant. However, if you go to the moon, it'll change. If you go to Jupiter, it'll change. However, if you go to Jupiter and you weigh 100 pounds, you'll probably weigh like 300 pounds, right? And so your weight has changed, but your mass, go ahead, the stuff that's in you, your mass and all that stuff, nothing has changed. You still have mass, the same amount of mass. You haven't grown extra heads. You still have the same stuff. It's just that gravity is working on you a little differently. Okay? So when we start working back here, we'll have balances on every one of the corners of these bench tops. And someone will come to me and you'll go, oh, I got a weight of this rod and it's 28.6 grams. They'll go, no, you didn't. No, it weighs 28.6 grams. I'm positive. No, it doesn't. It has a mass of 28.6 grams. So we'll get into talking that way. It doesn't have a weight, okay? As soon as we start doing space travel and stuff, we'll all start using this term mass a lot more and we'll stop using the term weight. What? Of course we are. There's already people going to space. What? The magic school bus? That's one place. I just thought they went into like the bloodstream and stuff. I didn't know they went to space. Oh, they went everywhere? Okay. So next, substance is a matter that has a constant and definite composition. So we use that term all the time, substance, but it's kind of probably important to understand what that means. So someone in first period asked me to give an example of the difference between a substance and something that's a mixture of substances. And I thought about this iPad, and I thought, well, if you were to pull this piece of glass, there's a piece of glass on here, off, it would be a substance. It's a uniform, has a definite composition, SiO2. So the glass that covers this is a substance. But if you were to take apart the rest of the iPad, you'd see it has all sorts of parts, right? It has electronics, it has all sorts of things. So it's not a substance. It would be a mixture of substances. So that's the easiest way I can describe it. Obviously, things like water is a substance. It's a constant, has a constant and definite composition. I would say that actually this material, this acrylic material is kind of a substance. It's uniform. This guy, my document camera, probably not. Okay? One way to think about it. Now, at any time, if I go too fast, just yell at me. Substances combine to form mixtures and compounds, okay? So they can either make mixtures or compounds. So substances is a pretty generic term for the most part. It's kind of a generic term. Okay. I usually try to look to see if people are writing still. So who's going to the dance tonight? Awesome. Yeah, be proud. That's good. Raise your hand. Oh, yeah? I always watch because when I did it, I noticed the ninth graders are always there first. And they're playing with the beach balls. Come on, that was you guys last year. Ah. Where are they having it? Because usually right out here, but the construction is there. Oh, just kind of, okay. Also, I'm glad I'm not doing that this year. I was like the bouncer 2 years ago at that dance. Messed up. Describing matter. So let's talk about describing matter. Okay, so this is this slide's there for a couple reasons. The first is you actually have already this was part of your homework to describe the difference between extensive and intensive. But sometimes I'll have a slide that has a lot of information, and we're taking notes. And what I want you to focus on is, for instance, the word extensive. And notice that I've highlighted this, and it says amount of matter. What I'm trying to do is sort of lead you towards that. When I'm taking notes, rather than just transcribe this and get into this mode of I'm a stenographer and I'm just like randomly jotting notes down, can you get to the point where you can write the word extensive and then write amount of matter, then can you write the word intensive and type of matter, and then could you kind of ignore the rest of this and feel comfortable with yourself? I found this as something adults are very good at doing. It's something that teenagers aren't very good at doing. There's this belief that you've got to write every last thing down, otherwise you'll miss out on something. And then you do that and you never go back and look at your notes sometimes, so it doesn't really matter. So what I will say is that this PowerPoint you can always find. If you go to my website right now, to Friday today, there'll be a little box that says Matter and Change on the calendar. You click it, there'll be a PPT file. It's this file. So you're not going to miss it if you don't have to, if you can't. If you have a problem finding it and you send me an email to my email, dressenchem@gmail.com, I'll send it to you as an attachment. A lot of times I'll put this slide up, and then I'll do another click, and all the words will disappear except for the words that I want you to take notes on. So it's sort of like what I would call guided note-taking. Okay? Get into that habit of guided note-taking. Okay? But let's talk quickly about extensive and intensive. Extensive is a property that depends completely on the amount of matter. Calories is a good example. I mean, if you have one hamburger, it has so many calories. But if you have 5 hamburgers, you actually have more calories. So calories does depend on the amount of matter. Intensive is a little different. If you look at carbon comes in 3 forms. One is your pencil. Another one is diamond. And there's another one called Buckminster Fullerene. Don't worry about that. It's kind of crazy. But everyone knows what a diamond is. And everyone probably seen some gold. And so there's a diamond and gold. Diamond is extremely hard, very hard. Gold is actually kind of soft. You can kind of pound it into sheets. So it turns out that the property of hardness doesn't depend on how much gold or how much diamond you have. It completely depends on what kind of thing you have, whether it's gold or diamond. So that would be an intensive property, okay? Intensive property. Okay? So those are usually the 2 types of ways to break matter down. Now, mixtures. Really quickly, mixtures are formed when 2 or more substances are physically combined. 2 or more substances are physically combined. Okay? Mixtures. And they can be different states of matter. So for instance, air is like nitrogen and oxygen we just talked about here. That's a mixture in the air of 2 gases, but you could also have a mixture of water and, I don't know, sugar water. That's a solid and a liquid, but they still make up a mixture. And there's 2 types of mixtures, so I'll put both of these up. There's homogeneous and heterogeneous. So maybe you write homogeneous mixture, uniform composition, heterogeneous mixture, uneven composition. I'll give you a couple examples. So for homogeneous, let's say Gatorade. It's got lots of stuff in it, mostly water, mostly sugar, but some phosphates, stuff like that. Homogeneous. Heterogeneous might be a protein drink. Can't see through it. It's maybe got, if you look closely, gobs of fat, believe it or not, from the milk could have. All those enzymes and stuff, all those things that are in milk and in protein. So it's actually more of a heterogeneous mixture. So a little bit on the edge is a heterogeneous mixture that we might call a colloid. But we'll talk more about that. But if you really want to know what a heterogeneous mixture, think of like, I don't know, like ice cream with all sorts of things in it, like Rocky Road or Moose Tracks or something. That would be a heterogeneous mixture. Okay? And so those are basically the two things that mixtures break down to, right? The same thing or different. Alike or different. Okay? Homogeneous or heterogeneous. So it looks like we've got about 5 minutes to go. End of a long first week. Let's see what I got here. And one thing I want you to realize is that mixtures can be separated by physical means. So I have some Gatorade, and someone says, you can't separate Gatorade. And I'm like, you bring the Gatorade to me over lunch, I can separate it. I have a thing called the distillation flask. I'll throw it in there. I'll set some stuff up. I'll get the heat going, and pretty soon I'll be boiling water off of there. Into another, it'll be pure water coming off and behind. You'll see the dyes, the sugar, and all that stuff. It'll be kind of a messy piece of solids. So I can physically separate it. Okay? What?
Can we do that?
We might do a lab like that later on. I got some money from Google. I spent about $8,000. I'm still wondering where they are. I got 3 of them. They're these kits, little microscale kits that each group will have. I have about 18 or 19 of them. They're kind of spendy. They're about $600 a piece. But we'll be doing that on a small scale.
What do they do? What do the kids do?
They're like little micro glassware kits. So they're like little distillation. They do little reactions and stuff like that on a small scale. Okay. So let's talk about compounds really quickly. We already answered this question during the warm-up the other day, but compounds are made when 2 or more substances are chemically combined. Okay. 2 or more substances are chemically combined, like sodium and chlorine make sodium chloride. So you guys already know that. And compounds are different from mixtures. When you have a compound like sodium chloride, you can't just take sodium chloride and pull it apart back into sodium metal or chlorine gas. You have to find a way to actually do a chemical reaction on it. Okay, so that would be taking it apart by chemical means, much more difficult to do. Much more difficult to do. And chlorine is really reactive, and sodium metal is really reactive. Sodium chloride is very unreactive, so it's really hard to take sodium chloride back to sodium and chlorine. It's energetically unfavored. And it says here the properties of compounds are different than their parent substances. Again, sodium metal, it's a metal, it's soft, you can actually cut it. Have you ever thought of cutting a metal before? But you can cut strips of it. If I pull it into the air, it'll start on fire. If I throw it in water, it'll explode.
Can we do some of that?
I'll do some demos with sodium. We have some now. And then chlorine gas is a nasty gas that if you breathe can kill you. It's toxic. But if you mix those two together, it makes sodium chloride, which we eat and need to survive. So exactly. So the properties of compounds are different from their parent substances. This is what makes chemistry so awesome. Yes, Evelyn.
How does the chlorine in your pool not kill you?
The chlorine in your what?
In your pool.
Because it's a different kind. It's actually not chlorine gas. It's an anion. But it does make a little bit. So people call it chlorine, but it's not actually chlorine gas. Okay. It's a chlorine anion. And we're going to learn about chlorine anions right here. Okay. But it still is somewhat irritable on you. Okay. So, why don't you guys look this down if you want to go ahead and jot that down. You can. I think it's in your textbook. But by the time we have a test or quiz on this area, one of the things I want you to be able to do is take any substance and tell me whether it's homogeneous, heterogeneous, or a compound or an element. An element should be easy. A compound should just be, okay, elements mixed together. These guys will be more like stuff. Yes?
Can I take a picture
Yeah, or you can go, yeah, you can take a picture of it, sure, that's fine. Or I think it's in your textbook, or you can just download the PowerPoint at your leisure. That's fine. That's pretty much it. I got about 1 minute. I'll do one last slide. Oh. This statement says that there's 3 states of matter: solids, liquids, and gases. Do you all agree?
Yes.
Yeah, it turns out there's 5, so this is a lie. Yeah, it's a lie. There's 5. In fact, they don't have the state of matter that makes up 99.999% of the universe. Is not up there. The other state of matter was just discovered in the year 2000. Oh, why don't you go figure it out this weekend? Yes?
Can I say which one of them?
Yeah, okay, Matt wants to try it. What's one of them?
I think plasma.
Plasma is the one that's 99.999%. Plasma. No, it's not fire. Plasma. It's basically what it is, state of matter the sun's in. So every star is a plasma. That's why it's 99.99%. Okay, what are you doing this weekend before the bell rings? 2 things. Study for the element quiz and
Get your thingy signed.
get your thingy signed. Yeah, perfect.
Is that all the homework?
That's it. Here, I'll tell you.